All right. Here we go. The first step, well, there's two things we're going to look at. We're going to look at how to measure angles, and we're going to learn how to make angles. And the first one is measuring angles. Okay, and here are the steps that you need to do in order to measure an angle. The first thing, and we're going to do this right away, step number one is you must decide if the angle is acute, right, or obtuse. Write this down. Decide if the angle is acute, which means less than 90 degrees, right, which means it is 90 degrees, or obtuse, which means it is more than 90 degrees. That is the very first thing you need to do. Okay, so we're going to do that right now on our paper because this is important here. Problem number one, that angle is obviously acute, so write that in the box under there. Problem number two looks very much like a right angle. Problem three is obtuse. You go ahead and write the rest of those in for 4, 5, 6, 7, 8, and 9. I'll give you a second to do that, and then we shall talk about this. You go ahead and see if I can grab a protractor here. Okay. Let's make sure everybody's got it. Problem number 4 is what, Ryan? Acute, obtuse, or right?
Acute.
Acute. 5 is Kelsey.
Obtuse.
Obtuse, it's more than 90 degrees. 6 is Christine.
Acute.
Acute. 7 is Calvin.
Acute.
Yes, it is very cute little angle there. Number 8 is Eli.
Right.
A right angle, and number 9 is 7 obtuse. Okay. Now I suppose right off the bat you could say that for problem number 2 and for problem number 8, although we better not do that because we actually have to measure that, I suppose, just to check. So let's not. Sorry for changing my mind. Now, step number 2 is this. Get that thing back up here again. Step number 2 on this is you must, because your protractors are relatively good-sized protractors and the angles written there are relatively small, step number 2 is if you need to, you must extend the angles lines so your protractor actually fits on it. In other words, this. See, if I take my protractor, which is what I'm going to measure these things with, and I put it on my thing here, the lines aren't long enough to go through the protractor. So you're going to need to take the straight edge of your protractor, lay it on this line, and drawing a straight line. This is not freehand, which I know some of you like to do. You need to take this line right here and draw it and make it longer so that it actually goes through your protractor. And it needs to be at the same angle and fit right there with the liner. So do that for problem, why don't you do that for 1, 2, and 3 right now. Make sure it starts at the vertex there. Do that for as much as you can for both sides. And I know the other side's probably going to run off your sheet of paper or whatever, but even that's okay. But they have to be long enough so we can use our measuring tool to measure them. And you can see what mine looks like there. Yours should look like that. Again, it's my hope that as a 5th grade level, nice job, Ariel. That's perfect. And you need to do this as accurately as possible because if you don't, it's going to skew your measurement levels. Same thing. This and then another thing, measuring is kind of an exact thing, but because we have some unexact worksheets being copied on a photocopy that can use some different things, and your protractors aren't always the best either. You know, usually I give you a 1 or 2 degree off whatever thing there. All right, now that we've got that, step number 3. Okay, and every protractor is a little bit different, so you have to adjust to the kind of protractor you have. Step number 3 is you need to find whatever it is your protractor has. Find the little hole on your protractor, and I'll show you where that is here. On mine, if you look at it here, this is mine. Yours has one somewhere around there. Either it's in the middle or on the top, or it's yeah, Evan's got the big round one there. You've got it there. The smaller the hole, the actual better this is. No, just there's one right in the middle that you use. You should know where it's at. No, you don't need the whatever that arm is. That's just goofy. Okay, find the little hole, and then you match it up to the vertex of the angle. In other words, you are going to take your protractor and you're going to move it so that that hole, see how mine, I can get it here, so that hole matches up to the vertex. You should be able to see that vertex in your little hole there. Okay, we're not done with that part yet, but I want to make sure you get that. Okay, now, here's where everybody's little protractor is different. Okay, on your protractor going through that hole, okay, you will see either some crosshairs or you'll see the 180-degree line way over here at the edge. Okay, you need to spin your protractor so that the line of the angle lays right underneath that line when you spin it. In other words, mine is going to look like this if I can find where the little turny thing is here. I need to turn mine. Where's the little dot that turns this thing? Anybody see it? Oh, there it is. I need to spin mine just a little this way so that when I put my little vertex in that hole right here, mine's just a little off still. I need to go a little this way. So see how my lines line up, the bottom of that angle lines up with the bottom of my protractor. I need to go just a fuzz more. Have that there, and I'm going to come around and take a look at what you have there to make sure you're at the good. See, yours is that 180-degree line. Right there, that little line there, and that little line there. So you have to spin this so that the 180-degree and that is there. That's not a very good couple, so I'll try that. Same thing. This little, you have a nice solid line. You just lay that there on top of it. And start out. Good. Perfect. Yes. Yeah, see, there's just that little line. Exactly the middle of the circle. You got it? You got it? I think you got it. I see you got it. Now, here's the other thing I didn't tell you, but you need to have your protractor going through the angle. You need to turn yours around so that Okay, now. What's that? So you usually have to use that 180 degree. So you have to put that 180 there. You got it. Okay, now here's the deal. In our little notes here. So we had that number 3 match up to the vertex and line up. We just did that. Line up one side of the angle. Now some of you, a couple of you had your protractor spun around because you could line this up like this with your protractor. You need to make sure that both lines of your angle go through the protractor because that's the only way we can measure this here. Now here is the deal. Here is how we find out the measurement here. Okay, there's my protractor there, and you can't see it because mine's, I'll try and make it a little darker for you. Oops, I guess that's okay. I'll try to make this a little darker so you can see it. There we go. Okay, here's the deal. This line up here, where this crosses up here, is the actual measurement for your angle. And here is the part I need you to listen very carefully because this is where everybody goes wrong, or most people go wrong. Okay? This line goes through right here at this point, and there's unfortunately 2 different numbers you can look at because see here, what number do you see here? 50, and here's 130. Okay, and your protractors will have the same thing on there. That is the very reason that we wrote this down below here. What type of angle is that? It was an acute angle. So in your mind, you have to tell yourself, I'm not using the 130 because 130 is an obtuse angle. Okay. Saved again by his mother? Is that the?
I'm sorry?
Saved again by his mother?
Grandma.
Grandma. Okay, so you have to right away say, since this angle can't be 130 degrees because 130 degrees is obtuse, you are just using the 50-degree measurement. And look, you have to be aware of the rest of the numbers with the 50. Here's 40, here's 50, here's 60 degrees. The line crosses right here at that line there, which is 1 degree closer to 40 degrees than it is to 50 degrees. So the measurement would be 49 degrees, because here's 40 degrees, 41, 42, 43, 44, 45, 46, 47, 48, 49, and maybe yours is 50, it's probably supposed to be 50, but the little 50 mark is right there. So this thing, when you measure, is going to be 49 degrees, and I would accept 48 or 50 degrees, but this one is, I get 48 degrees. So step number, whatever we're on, 4? Step number 4, you need to make sure if it's acute or obtuse. If you read the protractor incorrectly, you'd end up with 131 degrees. And there's no way that this small angle is 131 degrees. That's why the first thing you look at is it acute or is it obtuse? Right, you don't have to worry about because right is 90 degrees regardless if you did it. Alright, Sammy?
Mine says 53 or 4.
Well, again, depending on how accurately you extended this line and that line, if they were off one way or the other, in addition to that, my paper, when I put it on the screen, gets distorted. So yours is probably somewhere a couple degrees one way or the other. Don't go by what mine is because when I put it up on this board, it changes it, distorts it, and that's going to change the measurement, and the protractor could be distorted too. So, what's our common consensus? Should it be? Nicholas, you got what?
50 degrees. 50
degrees, and most people get 50s. Okay, if you got 50s, it's not going to be 69. It can't be 60 to 9. It can't be any of those. It's got to be somewhere close to 50 degrees. Well, it goes right through the 50. I'm not so sure how you get a 60 there. And that's 50 degrees right there, right on the nose. All right, let's try our little method here. Go ahead and measure and see if this is actually 90 degrees, and you're going to need to extend this line right here. Make sure it goes up nice and straight up there. Take your protractor slide it across.
Yep.
Get the vertex, put the vertex in the angle there. I'll make mine a little smaller here. My protractor seems to be a bit large. Hopefully it is 90 degrees. So again, you take your little protractor, put it there, make sure you spin it so that it's right on that line. And then, and again, mine's off just a little because I'm not exactly right in the middle. And mine ends up falling right on the 90-degree line or very close to it. Okay. Go ahead and measure the third angle, please. If you're having trouble, let me know and we'll take it, see if I can't help you out. So third angle, you would have written obtuse, so there's no way it can be a number less than 90 degrees. The third angle, you have to make sure that you want to put, and you want to put your protractor on the third angle so that you actually get a good reading. So you might want to put your protractor like this for that third angle. Sure. Yeah. Do the third one. I want the third one first. Let's make sure we get the third one right. Fourth one's going to be a little tougher. Fourth one will be a little bit more of a tougher. What you could do is put a piece of paper underneath of it, and as long as you keep the two pieces of paper together, you can make it as long as you want. Again, this should not be a guessing game to extend that side of it. Same thing with two. Take a look here. Let me give you a little helpful word of advice. For this problem over here, most of you extended this line over here, which is fine. Let me give you a little small word of advice here. It does not matter, children. Okay, and then I can extend this line over here. There are a couple different ways to measure this line. Most of you put your compass or your protractor on this like this and measured that long, and you kind of ran out of room over here. You could also spin your protractor like this, and you'll give you more room to measure the other angle that goes through it over there. You'll still get the same. It looks like mine ends up being close to 135 degrees. Yours is probably going to be relatively close to that. If you got 45 degrees, that meant you read the wrong side of the protractor because it can't be 45 degrees and be an obtuse angle. And that happens very, very frequently. Go ahead and measure the rest for me there. If you're having trouble, raise your hand. What's that? A couple of issues you're having is this. So that one, I'm going to go straight with this one. You need to come on. Generally speaking, they're not off by too terribly much. Raise your hand if you're having any issues at all. You gotta accept your line. Can't measure anything when the line goes through your protractor. You got to manipulate your protractor so that it's the wrong protractor. You will, by the way, make sure you will be bringing protractors from this point forward. So if you don't have one, have your folks stop by the store and buy the dollar thing because it will come up on quizzes. And I'll get very tired of you saying you don't have a protractor here. So talk to your folks. I don't care if it broke. That's still your responsibility. Have them pick you up one. Walgreens is right on the way.
I had 0. Before I got 3. I get it. You got 4 I got 86.
Alright, so your assignment is to finish up those things, take them home. We'll talk about drawing angles tomorrow.
Wait. Very slow.
Those of you that need to be poets, I need to come on back here so I can give you your assignments.
This is like my writing. Gary, I'm not that good at making. I like how they say.
Evan.
Yeah, okay. And I only have 5. Sure. Remember this again, you're studying I did not Remember the spaghetti sticks and marshmallows? You were just talking I was making words sometimes too. And I was like, I like the whole dude, Calvin, I like the whole bag of mini marshmallows. I was actually doing this. I was sincerely and then they had growing a beard. That's weird. I was so excited.
Kids write something down. Evan, you need to remember that. You are recorded. You are recorded. You need to write something down.
Heavy Torah.
Hey, why do you go?
Yeah.
You hate
They're gonna cry. Oh, you got two. Who keeps screwing my daughter? I didn't get this. So I just
Pick a number, please. Sit down.
He's going to four.
Hey, Kyle, pick a number.
Wow.
Do so. Yeah.
17.
Shine. Bryce. Nick. That's worse. Hi.
7.
Lauren.
29. Do not try.
Rich.
20.
Austin. Jackson. 4. Haynes.
16.
43. Johnny. Lucas Espanol.
7.
Kaylin. Allison.
15.
Brandon. Brandon, how about that assignment? You got that one? Then you weren't here on what day? Maybe the day after the class trip?
Yeah, I was here today. I was here.
The day before the class trip. Anything that had a 2 on it? Or is it set left, second line? Wait, that's the next day, well, that was the assignment that was.
And I can say what comes out.
I don't think you're understood this, it's supposed to be like how that had a 2 in it. It was much more than just 8 problems like that. Maybe all 22. Licht.
Yeah.
Shellhammer.
Oh, sweet.
Schwartz. Jack. Did I say Licht or Nick? Licht. Licht, yeah. Jack, Nick, Sage, Elson and Jackson, John, Austin, Lucas, Haynes, Affenberg, Brandon Norman, Nikki Kala, Emma Price, Hanuzo. Here we go, let's try it. 16 through 25 on 79. Number 16, should be a parallelogram, which is 65 feet squared. 17 would be $30 per hour. Number 18, here's a graph, 1/3 x. That looks a little bit like this. Goes through the origin, and it's kind of a flatter sort of line. Sorry, that didn't really go through the origin. Number 19, and no, the answer is no to that. Number 19, it said, Carmen Design Company logo used, and it says, draw 3 triangles separately, pointing to your 3 triangles separately. 3 triangles separately. Supposed to be 3 separate triangles. 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 The answers were x is 5, y is 7 1/2. That is interesting. I'm not using experimental points. So you're saying that's the work you're showing for that one? The work for problem number 23. Problem 20 is 314 feet cubed. Number 21 is 12 yards squared. 21 is 12 yards squared. 22 is 36 centimeters cubed. 23 is 30 pounds. You didn't finish today's either?
I have a question.
And you have a note from your parents and they try to help you finish? You hold on from Friday of last week till now? So you didn't try to go to school today, you didn't see them in the morning? They weren't home? But they weren't home last night? Okay. So you did have chances and opportunities. Oh yeah, 23. 23 was 30 pounds. 24, when you solve that, you get x is greater than or equal to 4. So you have a closed circle at 4 going to the right. And 25 is B. And letter B is the point Z, is the center of the rotation. However that might be. Lauren.
So for numbers 22, 23, and 24 and 25, I did the wrong set for those problems. So
Which one did you do?
I don't know.
Your task is to find that. Questions?
I have no idea. Oh, I did
So should I do those last ones?
That's always good. I would think, children, even if you don't understand a problem, you could at least sketch what the problem looks like from the book. I mean, for me to look at a blank square on a piece of paper, you know, that to me could just mean that you just forgot to do it, and then you're going to say you didn't understand it. For example, problem 24, why would you not write the equation down? That's just kind of interesting. Jackson Torak, well, we're here 25. 25, answer is B, and then it says, the coordinates for points Z and Z prime are the same. Why is that? Because Z is the center of the rotation, which wouldn't change. Much like the northern star in the light, in the sky. Everything seems to rotate around that, so it doesn't change point, whereas everything around it. That was that. Shell hammer. 19, x is 5, y is 7 1/2. Brandon.
What was it?
Number 20 is 314 feet cubed. Bryce. 17 was $30 per hour. Boomba.
I am confused on 20 and 21. It's just, I do not get it at all. And I was way off on both of them.
Anybody else?
Just 21. Yeah, just 21.
I'll start with 20. So Kyle, you drew the circle.
Yes, I did a very nice circle.
That's a good start. So you've got this cylinder, mind you, correct? Is yours as nice as mine or not?
I think this is a little nicer.
You know that this is 1 meter tall, and what was the radius it gave you was 10 meters. Then obviously, Kyle, you wrote down the formula for the volume of a cylinder, which was, it is not. Well, I gave you a separate one for volume of cylinder. You will not use volume equals length, width, height very often anymore. You should use the updated volume one, which is the area of base times the height. But cylinder, I gave you a very specialized one, which was simply the area of the base is a circle, so it's pi times radius times radius. That's the area of the circle times its height. That's all you need to know. It told you pi was 3.14, the radius is 10, and the height is 1. So it's just a matter of 3.14 times 100, which was where 314 meters squared came in. Then for problem number 20, it said a slab of concrete, 21 says concrete is ordered by the cubic yard. How many whole cubic yards should be ordered for this slab? Well, the difference, the problem with this is that really in meters? That's in feet, sorry. So this should have been feet squared, feet cubed, okay? And this is a true statement. When you call up the concrete place, if you would happen to be in construction or building something where you need concrete, concrete comes in cubic yards. Okay? So the basic gist is you have to figure out how many cubic feet are in 1 cubic yard. Well, that's not very hard because if you sketch out a cubic yard, a 1 yard by 1 yard by 1 yard cube, how many feet are in a yard? 3. So each one of these measurements is 3. So 1 cubic yard, 1 yard cube is how many cubic feet? 3 times 3 times 3. There are 27 cubic feet in a cubic yard. So how many cubic yards would you need? You would have to take 314, divide it by 27, because each truck will get you that. You end up with a 1 here, 44, and they said, how many trucks would you need? Well, 11 won't get you there because you'll be short. 12 will get you over, but you can't order a half a truck, so you have to order 12, and then usually the little concrete guy pours it off to the side somewhere, which makes it mess because it's hard to do the concrete. I don't think they usually take it back to the shop because you only have so long with concrete. That's why the little trucks spin. You ever see concrete trucks, they spin because that keeps it liquid. It keeps it moving and from setting. Because once it sits in a little spot for a while, it gets hard. Then you're done. Because if you let it set in a concrete truck, there's no way to get it out. I'm sure they'd have to go in there and hammer it out or something. But there you go. Now you're a little bit wiser when it comes to concrete. How many had both those right? Anybody? Huh?
I had 20 right, not 21.
Three did. Right.
17.
What about 17? 50 cents per minute? I believe in that name. I was just kidding. 50 cents per minute price, and you were supposed to change that into? And I struggle to see how difficult this might be for anybody because there's no thinking involved here. You are just changing cents into what? Dollars, and there are 100 cents in $1, and you are changing minutes, and it has to go up here to cross off into what? Hours, and there are 60 minutes in 1 hour. Your labels have all now just, oops, that one didn't cross off. Crossed off, you just need to do the math. It's 50 times 1 times 60 over 100 times 1 times 1, which ends up being what, 3,000 over 100? Which crosses off to give you 30, and what are your labels that are left? $30 per hour. I mean, there's not a lot of calculating there. You're just using unit multipliers to cross off labels. I mean, if you know how many minutes are in an hour and how many cents in a dollar, this doesn't get any easier than that. Lauren?
Back to the 21. I don't see how like 314 or 27. I don't get how 314 divided by 27 is 12. So
It wasn't. It was 11 plus a remainder, but like I said, you can't. You're talking about how many trucks of concrete you need. You can't get 11. You have to get. It's like painting a wall. Okay. If you only need to, if you paint 10 gallons and then you have another quart, you have to go buy the other gallon. You can't. There's no remainder. There's no leftover. You have to order the next truck. Or school buses. You know, 5 people fit on a school bus and you have 11 people. You got to get 3 of them because you can't just say, "Well, I'm going to push one more person on there," because that's against the law. And we could all go to jail for a very long time. Is that your question? You got 11 remained or something?
Yeah.
No, you have to have an extra truck. Nick?
Can you do problem 24?
Nope. 2x plus 2x plus 6. 2x plus 2x plus 6. And what was it? Greater than or equal to? Less than or equal to? Greater than or equal to. If this was an equation, Nick, what would you do?
I subtracted the 2.
This 2?
Yeah.
Okay, I'll go with that. And it goes with the 6 because it doesn't have an x. So now you have this. You have 2x is greater than or equal to x plus 4, correct?
Yeah.
Now what do?
I added the x to the 4.
You can't, but you can't. They're not like terms. You can't add an x with a 4. You need to subtract this x to get it combined with the thing you can put it with. 2x minus 1x is 1x. And that's where x is greater than or equal to 4 comes from. Okay, numbers don't get along with variables by themselves. Now if you multiply them, that's fine. You can put them together. But adding and subtracting them, it just doesn't happen. It's a little unfriendly that way. Oh, good thing we don't have much to do. Jackson?
I don't understand under 22.
Did we do 22? Did you draw the triangle pyramid?
Yes.
Did you write the volume formula?
Yes.
Which is what?
Plato systems.
Jackson, make me
Alright, let me rephrase this. You are not using the volume equals length times width times height formula. The only thing that works is for rectangular prisms. Okay? People get that in your mind. Now you're listening to me? See. Alright. The only thing length times width works for is a box. If it is a different shape, you have to use the other formula. This was a triangular prism. you have to use volume equals the area of the base times the height. And what shape? That's the whole loaf of bread theory. What shape was the base? The base is that triangle. So you have to find the area of the triangle and then multiply it by how tall that thing is when it's sitting on its base. How tall was it? How tall is that? What?
1 centimeter.
Oh, great. So the height is going to be 1 and it's not going to change anything. The dimensions of the triangle were 6 and 12 and 10. They did a little dashed line here. Is that 6? This was 6, this was 12, this is 10. What is the area of the triangle? And there you got to think about the 1/2 base times height. What two things form the base and the height? The right angle, which was this times this. So it's 1/2 of 6 times 12, which is half of 72 is 36, and 36 times 1. That shape there, the volume is 36, whatever was measured in centimeters cubed. You can only use length times width times height for boxes. No longer for any other shape. A pentagon, a hexagon, triangle, any kind of prism besides that, you have to use that. And it should say that in your notes. So that when you get to your notes, Lucas is man, you'll get there. Yes, sir.
So for that, you can do 1/2 length times width times height.
Well, I'm asking you, what did you use for length and width and height? And why would you use that for the length and width and the height? What is the length of that shape? And then what's the width? And then what's the height? Yeah, me neither. No, you gotta use area base times height. No, I'm not asking you, Shanks, not with that little evil grin on your face. Height?
Can I get paper on
I hope so.
Same.
What?
Paper.
Oh, that's fine. I thought you were gonna have some. One more. I hope it's the same one. Paolo?
I don't get number 23. I've got like a ton of different answers.
Well, I'm not sure there's more than a couple different answers you could get for that, but the first thing you have to look under is direct variation, I would suppose. If something varies directly, what does that mean? What did your notes say under direct variation? Do we have something under direct variation? Would somebody look at your notes and tell me what it says under direct variation? Because that would probably be a big clue. Wait, the person that's asking is not looking at their notes? Paolo? Look at your notes, Paolo. I want to see what your notes say. I know what it is. I want to know if we wrote down anything else. Who's got it there? First thing it says, it's proportional. As one thing goes up, so does the other. Direct variation. Y equals K times X. Oh, look, and then we did an actual problem that did it. It is actually proportional or a ratio. Okay, the ratio of what are we talking about? What two things are we talking about? Weight on the moon, weight on the sun, weight on what? Weight of an object on the moon varies directly with the object's weight on Earth. What's that? Right there next to Lauren. I thought I told her that. If an astronaut who weighs 150 pounds on the Earth, see we're comparing, look here, who is this, Kyle? We're comparing the Earth and the moon. Okay, and it said when somebody weighs 150 pounds on Earth, they weigh what, 25 pounds on the moon? Is that what it said?
Yeah.
Okay, well, what was the weight on the moon of an astronaut who weighs 180 pounds on the Earth? A direct proportion variation is nothing more than equal fractions, making, and then you can just do it just like this. 150 over 25 is going to equal 180 over 100. And how would you suggest I go about doing that? Yes, let's try reducing. Is 25 going to 150? 6 times. 6 times what is 180? So 1 times 30 is? Better be way off and not in the ballpark. Blank piece of paper, please. Oh, no. You know what I hate? This thing